Today I am going to discuss another part of this unit, actually acid base chemistry, and that is of course all the part is important, but it is also very important in terms of organic chemistry, or sometimes we call it structure reactivity correlation, or sometimes we call it correlation analysis in organic chemistry. And that is, and this year why it is important, because this year syllabi, because you are studying in third semester, so we have included this topic that is called linear free energy relationships and Hammett equation. I have already discussed you another aspect of the Hammett, that was acidity function. Don't confuse with the acidity function. Of course, it was discovered by Professor L.P. Hammett of Columbia University, but that is different. Here it is called Hammett equation, and that was Hammett acidity function, or sometimes it is called the linear free energy relationship. You might have heard about the nitration reaction of benzene. Suppose we take benzene and we take toluene sometimes, and if you want to study the reactivity pattern, maybe toluene is more reactive than benzene towards nitration. Similarly, there are a large number of organic reactions like Friedel-Crafts reactions or hydrolysis reactions or saponification of ethyl benzoate. There are a large number of reactions. So, how a substituent affects the reactivity, that can be studied with the help of that Hammett equation. And of course, there are a large number of books available in our library also. I will show you some of the books which are available in our library, that means Pandit Ravi Shankar Shukla University Library. And you can visit to the library and have a look of those great books written on that Hammett equation. Today I will not discuss the whole concept of the linear free energy relationship, because it is a very big chapter. There are some problems regarding the limitations of the Hammett equation. There are some problems related to the application of the Hammett equations, and there are many other concepts that is called the extension of Hammett equation, that means after Hammett equation. Okay. So before now you know that nowadays one thing is very important. What is the program outcomes? Second is the program specific outcome, and third is the, you know, that course outcome. So whenever you see our prospectus, you will find that whenever we prepare some of the new course, so we must add all such type of things. Why we study this Hammett equation? What is the importance of the Hammett equations and other things? So, and you must know the literature, you must know the important books related to the Hammett equation. There is the actually modern trends of that new education policy, and you have seen that during the presentation of NAG visit recently, when I have presented the things before the external committee, and they have already discussed with you that they have given emphasis on the teaching learning method. That is very important, and course contents and other things. So always remember that whenever you study any subject, whether it is a quantum mechanics or group theory or photochemistry, you must know why you are learning this type of things and course outcome like that. So therefore, you must know the. Now, fortunately, there are two very important books. You see, that whole book is based on that Hammett equation. I have the Xerox copy of that book, the Hammett equation by C.D. Johnson, very good book. And another book is also available in the library, because as I have already told you that there is a concept of the correlation analysis and the linear free energy. Why it is called linear free energy relationship? I will explain all these things by John Sauter, a very well-known scientist. Similarly, because this part actually Hammett equation is not purely physical chemistry, but this type of concept is sometimes known as physical organic chemistry. That is, of course, physical chemistry is required, thermodynamics is required, kinetics is required. So sometimes I can call it physical basis of the organic chemistry. In books, you check it, whether it is clear or not. So therefore, I have deliberately given two important books of the organic chemistry. One is, you all know, the fantastic book, Laurie and Richardson. And the name is, you have seen that, Mechanism and Theory in the Organic Chemistry. And when I was a student, still I have that book of the Peter Sykes. So I am talking about the 40 years ago. Still this book is very good. A guidebook to the mechanism in organic chemistry by Peter Sykes. This book is available in my lab also. And again I am saying this is a very, very popular book for the student of the organic chemistry. Reaction mechanism and structure. Because this Hammett equation is based on, or Hammett equation can throw some light on the reactivity. Or sometimes, what is the application of the Hammett equation? With the help of Hammett equation, we can figure out the reaction mechanism. So one part is also there in organic chemistry by Jerry March, and another book is also available in our library, that is the structural effects on equilibria in organic chemistry. So that is actually about the Hammett equation. Then you must know always, whenever you study anything, so you must know the first paper, because that is the starting point. So actually, if you ask me, sir, when that Hammett equation was discovered, because it is a long study, sometimes it is called the empirical relationship like that. So Hammett, in Columbia University, Professor L.P. Hammett published his first paper, of course, in 1930 to 1937, 6 to 7 years. And it was not like that Hammett discovered these things. When I will derive the equation, you will find that, sir, it is nothing but one of the extension of the Bronston catalysis law, where there is a relationship between the rate constant and the equilibrium constant. So, but Hammett Chemical Review is one of the best journal, and you cannot imagine the impact factor nowadays. So it is a dream of every student, every teacher. We should publish a paper in Chemical Reviews. So the first paper Professor Hammett published, some relationship between the reaction rates. You will be surprised when I will give the one relationship. So his first paper is the some relation between the reaction rates and equilibrium constant. And you are all good students, you know that whenever I am talking about the reaction rate, it is related to chemical kinetics. But whenever I talk about the equilibrium constant, whatever the equilibrium constant, definitely it is related to thermodynamics. So there must be some relationship between kinetics as well as the thermodynamics. His second paper he published in, again is a very good, because it is a research oriented teaching, and in fourth semester you have to perform some of the research projects. So you must know the types of the journals and other things. So his second paper is Journal of American Chemical Society in 1937, and then of course he has particularly taken some benzene derivatives. So that is the most important paper, and after, so therefore we just call it that Hammett equation, means it was discovered in 1937, because after this paper it was recognized, no, it is very important derivations, so therefore it is Hammett equations. So yes, please. So if I write one, because one thing is important that if I write benzene, suppose this is reactive center, and you can ask me, sir, why you have chosen the benzene? Not me. Actually, Hammett experiment is based on aromatic compounds, and that is when you study the extension of the Hammett equation, you can ask me, sir, why you are talking about the aromatic compound? What about the aliphatic compound? Don't worry, that is the extension. That means that substituent effect can be extended for aliphatic, but that is not proposed by the Hammett, but Taft. Sometimes it is called the RW Taft. So one thing is that in first case I would like to study the equilibrium, capital K, and second is the rate constant, number one. Number two, that this is center and this is substituents, and it is all, again there is a limitations. What is that limitation? That this X is only for meta and para substitution. Again you can ask, why not ortho? Ortho, meta, para, you know. Because there may be some, because in comparison to meta position and para position, ortho position is very close to, so there may be some steric problem, whatever. So my first definition is that if I take one benzene derivatives or whatever it is, so what would be the possible effect of these substituents on para or meta position, on the acidity or whatever it is, reactivity and other things. That can be solved by the Hammett equation. But there are two limitations. You can ask, sir, why not ortho? So this is my first question. That means the Hammett equation is related to equilibrium constant as well as rate constant. There should be no confusion. So therefore, you just focus it. If a substituent is attached to the para or meta position, of a benzene ring, it will change the ability of the aromatic ring to donate or withdraw electrons relative to benzene itself. Gradually, I'll explain the role of electron withdrawing group and role of electron donating group. And dear friends, large number of literature related to Hammett equation are available in the website. But I am just, because I am a teacher, so I am giving only the salient features of that. I will not give the much more example of like that. So, on the basis of, now what he has done, the starting point of Hammett equation, I must tell you. He has taken two systems. Number one, just you listen very carefully, then I can ask you the question. First question is that he has taken benzoic acid at 25 degrees centigrade. Para substituted benzoic acid. After this, I will show the data. Substituted. And X may be nitro, chloro, bromo, example, methyl, methoxy, large number of, and determine its you know this thing, K or pKa. It is purely thermodynamic stuff. Listen carefully. What he did? He has taken para substituted or meta substituted. Para and meta also, some meta. Benzoic acid and determine its pK. In the same time, he has taken C6H5, you know, this is ethyl benzoate. It is called the ethyl benzoate. Ethyl benzoate. You can write like that, substitution also. X. Again, he has taken para substituted ethyl benzoate. Some are not soluble in water, so he has taken 80% of ethanol. And temperature is again room temperature, 25 degrees centigrade, like that. And sodium hydroxide or OH. So you know that there is a formation of alcohol and like R, CO, Na or whatever it is. That is not important. And determine the rate constant. So some rate constant K2, of course, because you know that saponification of ethyl benzoate is second order reactions, Again and again, he has taken not aliphatic esters, but aromatic esters. Now you can understand that first part is it is related to K, equilibrium constant is related to thermodynamics, and this part is related to the chemical kinetics. Now I will show you the results. As you know that the pK of benzoic acid is around 4.22. Approximately, I am talking about these things. Suppose you are a good scientist, you add electron withdrawing group, you know that the role of electron, nucleophilicity and electrophilicity, where nucleus or electron goes to nucleophiles, like that. But in a nutshell, you can call it the some role of, and suppose I take the para nitro, it is suppose 3.9 or approximately, or maybe less or like that. And some are methoxy group, maybe 4.46 like that. And ethyl benzoate, rate constant 1, 2, 3, 4. And this substituted ethyl benzoate is also para nitro ethyl benzoate, para chloro ethyl benzoate, para bromo ethyl benzoate. And surprisingly, when you plot a graph, please listen very carefully because this is the starting point of Hammett equation. One is thermodynamics, no relation. Another is the kinetics. But when you plot a graph between the rate constant, whatever it is, log of K2 or whatever it is, and log of K or pK of benzoic acid. So there is a straight line. You are surprised that one case, one is thermodynamics, and then he thought why it is called the correlation analysis, and this is the starting point of LFER, sometimes LFU, because your question pattern is nowadays different, and I have seen that most of the students are unable to solve the very short answer and very short answer type of the question. They don't understand that one line or two lines. So it's very common question for the examination. Why Hammett equation is called linear free energy relationship? Why Hammett equation is called linear free energy relationship? That means there must be some relation, and Hammett solved that problem and discovered the great Hammett equation. On the basis of this, and large number of scientists, they have also studied, so sometimes it is called empirical relationship. So then he has studied large number of reactions and tried to connect kinetics as well as the thermodynamics. So now I am giving the results I have taken from the literature. So now what is our experiment? Number one is the determination of equilibrium constant or pK of benzoic acid, and second, determination of second order rate constant of hydrolysis of ethyl benzoate, or sometimes it is called the saponification of the ethyl benzoate at room temperature and I think aqueous alcoholic medium, more than 80% alcohol is there. So these are the results of this pK. I have taken from a literature, as I told you that there is large number of, so this is benzoic acid, and some are green color and some are, this is plus inductive effect, minus inductive effect, it is very common, but the thing is slightly different, that this green color, you know, methyl, methoxy, hydroxy is electron donating type of group, and this blue color is electron withdrawing group. What is important? That definitely these substituents do influence the acidity. You can call para-nitrobenzoic acid is more acidic than normal benzoic acid, whereas para-methoxybenzoic acid is less. That is different thing. So I am giving this experiment. Then I must show you the results of the ethyl benzoate. These are all available in the books because pK is very known value, and in your experiment also in first semester course you did this experiment, pK of benzoic acid by simple Albert and Sargent method, by simple titration method. Now this is the saponification of the ethyl benzoate. Now the result is that, again I am taking these values from a very good book, Physical and Mechanistic Organic Chemistry by R.A. Jones, Cambridge University, page number I have already given. That these are the, as I told you, 80% aqueous ethanol, and I have taken from a book, but he has also taken from some other work because somebody has done this experiment. So you see that these are the substituents, paramethoxy, like that, methyl, like nitro. You see no ortho, everywhere either meta or para, either meta or para. So these are the rate constant, relative rate, and you have seen that when I have taken the nitro group, the rate, relative rate is very high. That means first case what you have seen in the pK of benzoic acid, when we add para-nitrobenzoic acid, the acidity is increased. One observation. In the second observation, that if I introduce para-nitro group in ethyl benzoate, the rate of reaction is increased. Relative rate is 104. Whereas if I take para-methoxy ethyl benzoate, you see rate of reaction is decreased. That means in both the cases, whether we are talking about the equilibrium constant or we are talking about the rate constants, are affected by these meta and para substituents. Okay. So on the basis of these simple observation, Hammett proposed two general equations, which is very simple, and most of the interviews I ask the question for a school teacher or university, what is Hammett equation? No discussion, just you tell me what is Hammett equation, like what is Arrhenius equation, like that. Simply tell me the Hammett equation. So don't forget these things. The simple, very simple, no differentiation, no integration. It is a simple logarithm relationship is Hammett equation. So never forget this, is very simple. So this is the actually relationship. You see that one is the log of rate constant and pK of para-substituted benzoic acid. Of course, there are certain scattering, but there is a linear relationship, and this is just a symbolic thing. But again, you just focus it. So it is a simple race. This is the starting point, but this is the original value. Again, I have taken from this book of John Sauter, but because that is a book, but actual work was performed by Ingold, of course, in Journal of Chemical Society, 1936. I am talking about the 1936 because it was discovered in 1937. So you see that this is the log of ethyl benzoate and pK of the benzoic acid. You have seen that in the extreme end, para-nitro, and after this lecture, I will give some one or two numerical problems, because again it is important for examination point of view, that how to determine the reaction constant for the Hammett. I will come to that point. So I will not discuss in this video lecture, but I will give some homework so that you don't worry about the graph paper or other things. Very simple, ordinary paper you can solve it. But thumb rule is that there must be, we must know why why it is called linear free energy relationship. Again, for the student, I must tell you another graph. I have also taken from, what is the difference between first graph and second graph? Difference is that here the first graph is aromatic, ethyl benzoate. Second graph studied by other scientists like Evans, 1940, 1938, 1939. That is the limitation of Hammett equation, where there is a large scattering. You see methyl there, butyl there is a large scattering. So therefore, today I will not discuss the limitation of the Hammett equation or the extent. I do not know whether it is in your course or not. That is called the Taft equation. That was, and for ortho, that is also different. Yes, for ortho, that is called the ortho effect. For aliphatic compound, yes, there is other linear free energy relationship. So I am just for your general knowledge that it is only for aromatic compound, not for aliphatic compound. If we take the aliphatic compound, there is a scattering. So that parameter is not. Now please listen very carefully that this is the final equation, no derivation, nothing. Final derivation is that there are two forms of the Hammett equation. One form, log of K equilibrium constant of the, you can write substitute x. That means equilibrium constant of the substituted benzoic acid or substrate, and K0 is the equilibrium constant of the parent compound like benzoic acid. Similarly, log of K means the rate constant of substituted compound, and K0 is the rate constant for parent compound or unsubstituted compound. Now, what about this two part? Now, this first part is called reaction. This part is called the substituent constant, which is independent of any types of the reaction. Again, you just look very carefully, listen very carefully. This sigma and rho value. So one is substituent constant and another is, this substituent constant is independent of chemical reaction. It is a constant value. For paranitro, there is a value. For paramethyl, metamethyl, different value. But this is reaction constant. Sometimes it is called the sensitivity of the reaction, or it depends upon the types of the reaction. So on the basis of this reaction constant, you can throw some light. Now, last question, that how you comply the Hammett equation. That means why it is called the simple linear regression analysis, because we all know y is equal to mx plus c. So if I plot a graph between log of k by k0 or log of k by k0 with respect to reaction constant, with respect to substituent constant. So this value is the m, slope value. Slope value is the reaction constant. Now, is there any graph? Yes. So sometimes whether Hammett equation is complied or not, or Hammett equation is valid or not. So what you will do? You will plot a graph between log k by k0 with this substituent constant. Of course, the value of substituent constant may be minus as well as the plus. I'll come to that point. When it is plus, why it is plus, why it is minus. And similarly, the value of reaction constant may be plus as well as maybe minus. It depends. If it is plus or greater than 1, we assume that yes, there is a effect of substituents, significant effect. If it is negative value, that means the effects are not very significant. Now these are common values. It is available in any books because it is the constant. So don't worry about this is the extension of the Hammett equation. You just concentrate only on this substituent constant for para position, substituent constant for the meta position of different types of, and this hydrogen is benzoic acid or it is a reference, it is 0 value. Now you see why it is plus and why it is negative, and how do you calculate this substituent? How do you or Hammett calculated this value? Why it is plus and why it is negative? I will come to that point. Now this reaction constant, or sometimes it is called the sensitivity. Now I am coming to the application of Hammett equation. Now if the reaction constant rho value describe the susceptibility of the reaction to the substituents, and the information on the reaction and the associated mechanism can be obtained based on the value of that reaction constant. You can ask me, sir, what is the application of this reaction constant? So I will tell you that on the basis of this value, we can predict the reaction mechanism. Example, suppose I will give some numerical problem after this class for homework. Suppose you have plot a graph between log k by k0 and substituent constants, and your slope value is positive. So that indicates that the reaction is facilitated, the rate constant, by introducing the electron withdrawing group. Suppose I have taken the simple ethyl benzoate and I have taken para nitroethyl benzoate. So the rate constant of the para nitroethyl benzoate will be increased. Suppose I am getting the negative value, reverse plot, negative value less than 1. So what I will predict? I will predict that the introduction of the electron withdrawing group or the substituent decrease the reactivity of the aromatic substrate in a reaction. Then that reaction series will have a negative period. And if it is 0, it is not like that. So no sensitivity to the substituents. Now I am talking about the substituent constant, and I will also explain that how substituent constant can be calculated. So first thing is that it is independent of the nature of the reaction. Suppose you are doing acid catalyzed hydrolysis of ethyl benzoate, and on the other hand you are using the saponification of the ethyl benzoate. So in acid catalysis also for para nitro you will take same value, suppose it is 0.71. For base catalysis for nitro you will take 0.71. So it is independent of the nature of the reaction. But if it is less than 0 or greater than 0, that means that it is the functional group R attracts the electrons stronger than hydrogen, like nitro and other things. In the opposite, if it is less than minus another. So it attracts the electrons weaker than hydrogen. Now actually, one of the limitation of Hammett equation is that he is unable to separate the polar effect, sometimes it is called the electronic effect, steric effect and resonance effect, because it is purely organic chemistry. So separation of polar effect, separation of steric effect, separation of the resonance effect cannot be studied by the Hammett equation. So therefore sometimes it is called the linear regression analysis. Simple y is equal to mx plus c. But you know that in organic chemistry there may be multiple effects. So therefore they modified that equation, that is called the multilinear regression analysis. So that's how you calculate this polar effect, steric effect and the resonance effect. Now I am coming to the last part of this, how you calculate the substituent constants. Before that, I must tell you why it is called the linear free energy relationship, last part, and then I will solve some of these are numerical problems. Again, it is available in the literature, other things. I will explain the things, but before that, I must tell you why it is called linear free energy relationship. Okay, very simple, very simple. Y L I L F E R, linear free energy relationship. Very simple and important also, because that is the main point of. First point is that if I talking about the equilibrium constant and rate constant, there are two terms. Now you all know that, and the plot I have already pK and log of K. Hypothetical, I am just talking the hypothetical case. Maybe some scattering, maybe some scattering. So K, we know that most important part, you all know, one of the very important part of the thermodynamics, and there is a lot of conceptual controversy about the actual definition of the free energy. Sometimes we call it free energy, sometimes we call it stored energy. Why it is called the free energy? Sometimes it is called the function, Helmholtz function, and but in spite of that, we know that there is a terminology, standard free energy. Okay, it is equal to minus R. Is very, very common, very common. So there must be some relationship between the free energy and the equilibrium constant, or we can call it natural log of K delta G by R, or sometimes I can call it log of (2.303 R). So second point, that very simple. If I write Hammett equation log of Kx substituents divided by K0. Very simple. So if I write here log of Kx minus log of K0 is equal to, this is equal to, if I take benzoic acid C6H5COH, just if I take benzoic acid, so I can write here log of K of C6H4COH is actually substituted, X minus log of K of benzoic acid. You know that minus log of pk is minus log of K is equal to pk. So I can write in red color pk of 0, that is benzoic acid, minus pk of x substituted is equal to, how he discovered the values of substituent constant. Now you can understand these things. That means if I know the pK of benzoic acid, suppose this is 4.2, suppose the pK of benzoic acid you have determined is 4.2, and pK of, suppose you take the nitro group, that is suppose 3.7 or 3.4, like that, 3.4. If I nitro is suppose 3.4. If I take my old first, 4.2 and it is 3.41. Okay, 3.41, and just remember methyl is 4.34. Just remember 4.34, 3.41 and 4.34. Nitro 3.41 and methyl I think 4.34. I just want to calculate the substituent constant. So 4.2 minus 3.41, .79, 0 point approximately. Follow my point or not? Now for methyl, pK is equal to 4.2 minus 4.34. Value is minus 1.14. You follow this? Is not very simple. So just now let me check. So we are getting substituent constant for nitro is 0.79 and for methyl is minus 0.14. So value of the substituent constant, yes, you can write from there. So nitro is around 81 or whatever it is. For meta is plus 0.7 and methyl is minus 0.14. So so simple. That means it is not in a rocket science. So Hammett, now you can understand what is the actually substituent constant. So on the basis of very simple calculation, Hammett determined the all types of substituent constant. Okay, now last part. Okay, what now again question, last point is again there. Why it is called the linear free energy relationship? So by that method you can calculate any substituent value. That means here methoxy you can write, chloro you can write. Now why it is called linear free energy relationship? Last part. Any idea about these things? Any idea? So Hammett was convinced, yes, equilibrium constant is related to free energy, absolutely no problem. Then he thought that where there is a relationship between free energy and equilibrium constant, so there must be a relationship between rate constant and free energy. Any idea? Any idea? Any idea which relates rate constant with any type of free energy? Any? कोई भी बताए क्लास में? Very simple question I am asking you. Delta G is equal to minus RT log K. Everybody knows it. Now my second question is that because I have to correlate between the rate constant and equilibrium constant. So is there any relationship between rate constant and free energy? Yes, of course. Just remember activated complex theory. So that is nothing but Boltzmann constant T H exponential minus free energy of activation. And if I write complete, because delta G is equal to delta H minus T delta S, so we can write this equation K is equal to KBTH exponential minus delta H exponential delta S R. So that means if I take again logarithm, so log of K is equal to log of KBT H minus delta G by RT. Or if I log, so 2.303. So that means there must be some relationship there must be some relation. Now if I just compare this like log of K0 minus Kx, sorry, log of Kx and K0 sigma. So you can, in place of log of Kx, we can write log of Kb T H delta G RT minus this thing. So if I just compare it, so it will give the delta H 2.303 RT, same thing. So Hammett, so therefore it is called the linear free energy relationship. That means there is a relationship between these delta G must be related to some constant like that, delta. Therefore, it is called the free energy relationship, Hammett equation like that. So lastly, I am giving one numerical problem for your home. So why I have shown this picture? By that picture you can understand the role of Hammett equation, how we calculate the substituent constants and other things. And I am giving this one example. Just I have given these two examples, methoxy group and methyl group. So thank you very much. So thank you.